Good day everyone, I am Juntilla of BSME 3A, and now I will discuss the concepts of stress under the course Fundamentals of Deformable Bodies and answer a problem afterwards and application of the topic we will tackle. Now let's give a short introduction to mechanics of deformable bodies. Mechanics of deformable bodies deals with the study of resulting stresses and strains developed in bodies as a result of external influences or actions. This will help us study or determine deformations a body will undergo when it is subjected to an external force and how much a load or forces a body can withstand. Engineers apply this knowledge in designing or analyzing different systems and load-bearing structures. And now, let's proceed to stress. Stress is defined as the total force or load or intensity of forces distributed over a given section. The SI unit of stress is Pascal, which is equivalent to newtons per meter squared, and its US customary unit is PSI or pound force per square inch. When the force acts perpendicular or normal to the surface of a body, it exerts a normal stress. Positive sign indicates a tensile stress, while negative sign indicates compressive stress. Now, when a force acts parallel to the surface or cross-sectional area, it exerts a shear stress. The equation for the shear stress is shown. Now to understand more about the topic, let's answer problem 1.34 applying the concept of stress. The problem states that a steel pipe of 300 mm outer diameter is fabricated from 6 mm thick plate by welding along a helix that forms an angle of 25 degrees with a plane perpendicular to the axis of the pipe. Knowing that the maximum allowable normal and shearing stresses in the directions respectively normal and tangential to the weld are 50 megapascals and 30 megapascals, determine the magnitude P of the largest axial force that can be applied to the pipe. The given parameters of the problem is shown. Now let's proceed to solving the problem. First, we need to solve for area, for which inner and outer radius are needed. For outer radius, let's divide the given outer diameter by 2. For the inner radius, as shown, we need to subtract the outer radius by the given thickness. Then, we can already determine the area. Next is to determine the loads under 50 megapascals normal stress and 30 megapascals shear stress. For 50 megapascals allowable normal stress, let's use the equation normal stress is equals to the load cosine squared theta over area. Then rearranging the equation and substituting the given parameters, the load is 337,341.23 newtons or 337.34 kilonewtons. Next is to determine the load when the allowable shear stress is 30 megapascals. To find the load at given shear stress, let's use the equation shear stress is equals to load sine 2 theta over 2 times area. Then rearranging the equation and substituting the given parameters, the load is 434,058.37 newtons or 434.06 kilonewtons. Remember that we are asked to determine the magnitude P of the largest axial force that can be applied to the pipe, and we arrived to two different values of loads. Note that the smaller value is the allowable load P. Therefore, the magnitude P of the largest axial force that can be applied to the pipe is 337.34 kilonewtons. That would be all. This is Juntilla of MA3A, and thank you for watching.